Hi, welcome to our first Survey Design Express video. ACTech has been in business for about 6 months now, and we thought it was time to show you what we can do with our TesserACT survey design software. I've actually been using the software for about 2 weeks now, and I'm going to show you what we can do with a marine streamer survey in an obstructed area. We'll start with a basic survey layout, and then we'll adjust the lines to avoid a couple of obstructions in the survey area. We'll analyze the coverage and estimate the time to acquire the project. Then we'll use a few orthogonal lines to fill in the hole in coverage around the platforms. And finally, we'll take a quick look at a couple of new technologies that can improve the quality and efficiency of an infill project like this. We'll take a look at a more effective automated solution using marine streamers, and we'll also look at how you could use seabed nodes to acquire the project using the shots from the marine streamer survey. If you look in the lower right hand corner, you can see that I've highlighted the time with a red box. It's 9:30 and I'm hoping to finish this project by lunchtime. I'm going to start by importing culture data. I can do this with a simple drag and drop user interface. You can see that I've imported bathymetry data, lease block maps, and the locations of all the platforms within our survey area. The first step in our survey design is to define the area that we wish to image. We've already used TesserACT's geophysical analysis module to determine some key geophysical parameters such as the aperture required for the project. With the geology dipping predominantly to the southeast, we've extended our target area more to the southeast than to the other side so that our migration aperture will capture all the data we need to image the target area. We are now ready to create the survey. The goal of this near-field exploration survey is to identify and define small targets that can be produced from existing infrastructure. The survey is quite small and short offsets are considered important, so we're going to use a fairly simple 6-streamer shooting configuration. And now we're ready to lay out the survey. If you look at the red box on the left, you can see that we now have our preliminary estimate of the time to acquire the survey. If you look at the box on the lower right, you can see that we've been working about 8 minutes in order to get this preliminary time estimate. At this stage, the time estimate is very preliminary. It does not yet include any estimate of downtime or infill that may be required during the project. If we zoom in a little, we can clearly see the challenge that's posed by the two platforms in the survey area. We're going to have to deviate our lines around these obstructions. There are smarter, easier ways to do this in TesserACT, but for this exercise we're going to manually edit each line. You can see that manual editing is very simple, much like editing an object in PowerPoint. Before we move on to start the binning process, I want to make a quick check to make sure that we don't have any of the vessels or trailing gear intruding into the exclusion zone. Don't worry too much about the clumsy streamer shape. We can update the streamer shape to a more sophisticated model later in the process. Now we're ready to start binning the project and look at the coverage. TesserACT's binning wizard offers intelligent defaults for all the parameters of the binning. Once binning has been initiated, the task manager on the right appears so that you can keep track of the progress of your project. Unlike some older applications, TesserACT is multi-threaded, which means that once you've set a binning job going, you can continue to work in TesserACT on your other projects, or you can go away and take care of your other business. As you can see here, I'm registering for the SEG convention in September, while TesserACT performs all its calculations. After a few minutes of calculation, we can look at the fold map for our project. Of course, the big problem is around the platforms. If we look at the offset distribution plot for a cross line going through the two platforms, we can see the two holes in our coverage. The offset distribution for an inline going through the northernmost platform is even more interesting. You can see that there appears to be a little bit of long offset coverage underneath the platform. How can this happen? Well, the answer is simple. With a 6-kilometer streamer, as we go around the platform, we actually undershoot the platform with our own source into the long offset traces. We can look at the maximum offset available in each bin, and then we can look at the minimum offset available in each bin. I'm going to turn off the bathymetry so that it's easier to see what's happening in this minimum offset display. And finally, here's a short offset fold display. It's clear that we have to do something about these holes underneath the platforms. The first step is to create a small grid of orthogonal lines. And then we must deviate these lines around the platform much as we did with the main grid. Notice that in this case, we've deviated all the lines in parallel in order to minimize the number of lines necessary to fill in the hole in our coverage. The orthogonal grid of lines has added about 2 days to our total acquisition time. Now we're ready to create binning displays that combine the coverage from the main lines and the orthogonal lines. The short offset fold map shows that we've reduced the hole in coverage to small squares around each platform, and the minimum offset display tells us the same story. The offset distribution plots highlight how well we've filled in the missing coverage underneath the platform. We can look at both the inline and the crossline displays. If you look at the clock on the lower right, you can see that we've completed this whole exercise in about 3 hours. I'd like to take a minute to consider what other options are available in TesserACT to mitigate the remaining holes in coverage. One option would be to acquire additional data under the platform using seabed nodes, and this is an option we're going to look at in a few seconds. In our little case history, we didn't use overlapping bins, and we could certainly have done so in TesserACT. We can flex the bins, and we can have the bin flex be a function of increasing offset. Realistically, bin flexing is not going to fill in the kind of holes that we're left with in this project. Another approach would be to model the effect of using advanced data processing technique. The use of multiples to image shallow targets is becoming increasingly popular, and the use of 5D interpolation is also becoming increasingly common. TesserACT will soon be able to model the effect on coverage of both of these techniques. Let's briefly review. We did a basic survey layout, and then we deviated some of the lines to avoid the obstructions in the survey area. We analyzed the coverage and estimated the time to acquire the survey. And finally, we acquired a grid of orthogonal lines to infill the missing coverage underneath the platforms. The whole exercise was completed in less than 3 hours, of which only 1 hour of my time was consumed. And now I'm going to tell you that most of what we did today is already obsolete. In TesserACT, we're already implementing automated and optimized obstruction avoidance protocols. Another approach that we could have used to acquire data under the platform would have been to deploy seabed nodes and then record data from the marine streamer shots. This is certainly an interesting approach and one we might look at in a future video. That's all we have time for today. I'd like to thank you for your attention. I hope you found it useful and informative. Look out for more Survey Design Express videos coming soon, or give us a call if you'd like to arrange a private demonstration or a free trial of the TesserACT software.